Welcome to another lecture. So today we'll discuss what is the potential difference between any two points. So you can see here I have taken two batteries. So there is 2 points here A and B. So these 2 points A and B. So I want to find out what is the voltage difference between or potential difference between these 2 points. So let us assume that here the potential across the terminal A is VA and potential across this point is VB. I am naming as VB. So I want to find out what is the potential difference between VA and VB. So VAB means we want to find out VA minus VB. So that means voltage across A minus voltage across BB. So that will write down VAB. So when we will find out this type of problem, so always you remember always you are taking the potential with respect to ground, and suppose any voltage across point A, that this is VA. So assuming that this is a positive voltage, that means VA is greater than 0. Similarly, the voltage at point B, that is also greater than 0. These are always greater than 0. So we'll redraw this picture. So you can go down. You can see here. So I have taken the same diagram here. The 2 points. So as I told that we are counting voltage VA, which is always with respect to ground. So let this is your VA, and we are taking this voltage with respect to ground. And similarly, voltage here at this point B is VB, and we are calculating the voltage with respect to ground here. As you know that the ground voltage is 0, so VA we are calculating with respect to ground, VB also we are calculating with respect to ground. Okay, so ground means 0 voltage, so here also 0 voltage. So both are grounded, so you can see that this is a virtually grounded, or the circuit is virtually connected. The circuit is virtually connected. As I told that VA is greater than 0, so you can assume that this voltage is positive and this voltage is negative or very less. Similarly, this voltage VB is positive, the ground voltage we can assume as negative. And as you know that this is the battery, so we can put this voltage is, this is a positive terminal, this is a negative terminal, and this is a negative terminal, this is the positive terminal. Now we can apply KVL here. So now this is a the virtual circuit. You can see here this is circuit is complete. Now we can apply KVL here. So let us, I am applying KVL. I am taking my motion is in clockwise direction. So what I will get? I will start from this point. I will start from this point. I will move in this clockwise direction. So when I will move from 0 to B, that means my voltage is increasing. I am going from minus to plus. So I am gaining some voltage. So what voltage I am gaining? 0 to VB. So I can write down. So I can write down this is your plus VB. Then plus to minus I'm going, that is means I'm losing, so I'll write down minus 10. Then similarly when I'll go for minus to plus, that means I'm gaining something, I can write down plus 3 volt. So when I'll reach at the point A, I have to go to this 0 voltage. So here you can see I am, so voltage is losing, or the voltage is falling. So falling means minus or plus to minus, I can write down minus, I can write down minus VA, you can write down minus VA equal to 0. So if I will simplify the circuit, so I can write down, I will take VA minus VB is equal to minus 7. So VA minus VB is nothing but your VAB, this is nothing but your minus 7 volt. Suppose somebody will ask what is VBA? Suppose somebody will ask what is VBA? So VBA is nothing but, so VB minus VA, that means voltage at the point B is highest potential, voltage at point A is lowest potential. That's why you are calculating VB minus VA. So VB minus VA, we can find out this is 7 volt. If you calculate VB minus VA will be 7 volt. So here you can find out VAB is nothing but your minus VBA. Okay. So in this way we can calculate the potential difference between any 2 points. Always remember, any voltage at any point we are calculating always with respect to ground. Thank you.